Everyone, and welcome to today's video. Today we are going to look at some important topics in process management and operating systems. My name is Manas Pathak and I'm a student of IIPS DABV. So let's start. So today's topics for discussion are the process concept, where we are going to look at what a process is, how it executes, and what is difference between a process and a program. Then we are going to look at the possible states a process can have and the complete life cycle of a process. First, let's start with the process concept where we define what a process is. All the CPU activities such as running programs, applications and supporting its internal programmed activities such as memory management are called processes. So any activity which is done by the CPU is a process. It could be explicit such as a command to run certain program which is given by the user, or it could be implicitly done by the user, implicitly done by the system itself. For example, loading of the operating system into the main memory by bootstrap loader. They are also referred to as jobs in some operating systems. So both the terms processes and jobs are used interchangeably. Both of them mean a CPU activity. So now let's clear a very common point of confusion, that what is the difference between a program and a process. A program is a passive entity, whereas a process is an active entity. A program is a file containing a list of instructions that must be executed, often called an executable file. So a program is an executable file that can be executed. So when this file is executed, it is called a process. So a process is basically a program in execution. A program is stored in secondary memory. So that is why a program is actually called considered a passive entity, because a program rests in the secondary memory until it is loaded into the main memory and a process is born. A program is static in nature, whereas a process is dynamic in nature. A program is just a set of instructions, whereas for a process, other than the program code, which is also known as the text section, a process is also equipped with program counter and associated resources to represent current activity. So other than the text section, a process also consists of a program counter which points at the next instruction to be executed, and other associated resources which basically define how memory associated with a process is managed. For a given program, there can be several processes associated with a program, but each process, all the processes, they do not share the same memory. They only share the same text section, whereas for a different process, there is a different set of program counter and its associated resources. Even if all processes are associated with a single program. The logical memory stack. Now let's look at the logical memory stack which is associated with every process. First is the text section, which is the compiled program code. Then we have the data section, which contains the global variables. The heap is the memory that is dynamically allocated during process runtime. Whereas stack contains the temporary data such as function parameters, return addresses, local variables, etc. Now let us look at the process states. Here we are going to understand the complete life cycle of the process and various possible states a process can have. As a process execute, it changes its states defined by its current activity. So the current activity of the process would define what is current state of a process. So first we have when a process is created, it is in the new state. So when the instructions of the program or a process are being executed, it is in the running state. Then a process might have to wait for certain event to occur. For example, it could be a completion of an input output or reception of a signal. In this case, the process is in the waiting state. Then we have the ready state, which means that process is waiting to be assigned to a processor. And at last we have the terminated state, which means the process has finished its execution. For a given processor, at a time only one process can be in the running state, whereas there could be many processes in the waiting or ready state. Now let us look at the complete transition network associated with a process. The order in which we define the process states here is not a chronological order of how a process transitions in its state. Here is the complete map of how it transitions from one state to another. So when a process is created, it is in the new state. Then from that new state, the process is admitted and gets into the ready state. Then through a series of interrupts, the process communicates to the CPU that it is in the ready state, and the schedule dispatcher converts the process into running state. So while running, a process might have to wait for an event to occur or complete an input output operation. So in this case, the process is in the waiting state, and when that input output operation is completed or the event occurs, with the completion of that event, the process goes back into the ready state, not the running state, because while that process is in the waiting state, the CPU might take another ready process and execute it. So that other process needs to be completed first. It either gets terminated or gets into the waiting state. So after a while, this ready state process gets back again into the running state, and once the process has completed its execution, it exits and goes into terminated state. So that is all for today's video. I hope you learned something from here. I would like to express my heartfelt gratitude to Dr. Basan Namdev for guiding me throughout the semester. If you learned something from here, please consider liking this video and subscribing to my channel. You can drop your questions in the comment section and connect with me through Gmail. I'll see you in next video. Thank you so much.